Okay, we're going to go ahead and get started. We're going to start with our chem chart today. And just to remind you what this chem chart is about, the first thing, remember, chem chart is because we have K-I-M. Okay? K stands for your key terms. Okay? These are the words that are important in this lesson. I is important information. Not just the definition, but it also talks about how it can be used in this lesson. M is for the memory devices, which we draw to help us to remember the important information about that. Okay? And remember I told you guys that we can fold it. If we fold the K backwards about a third of the way, and we can fold the M backwards about a third of the way. We can turn this into a study guide, something to help us to study with, okay? And that way we'll only see one section at a time. We can look at the key terms first and see if we know what they are, okay? If we're unsure, if we open up, then there will be the memory devices to hopefully give us a hint. And then, of course, if we still don't remember, we have our important information on the back that we can go back and review. Okay? Chem charts are very important to the lesson. A lot of the time, quizzes, just like for Unit 1, quiz material comes directly from this, so it's very important that you take this home and study. Okay? Now, we already have the key terms and the important information filled out. What we're going to do is go and look at our memory devices. Okay? You need to draw your memory devices. Sometimes I'll let you draw your own picture, but when I think it's important for me to give you the example, then I need for you to draw what I draw. And today, I'm going to need you guys to draw what I draw. Okay? It's very important that we do that. Now, let's start with the first one. The first key term is divisible. And if we read what the important information says, divisible means one number goes into another number evenly. Okay? One number goes into another number evenly, and that number must be greater than 1. Okay? Remember when we talked about, let's go down in it. It says it must be greater than 1. Prime numbers do not have divisibility. Okay? Remember our definition for a prime number is it only has two factors, 1 and itself. So that means that it does not have divisibility. So if we can divide a number bigger than 1 into another number evenly, that bigger number has divisibility. Okay? So for our memory device, we'll use the number 20. And we want to check to see if 20 has divisibility. If I write it on the board, you need to write it down on your paper. Okay? We want to see if 20 has divisibility. Are there any numbers that you can think of that goes into 20 evenly? 4. Okay? So we're just going to use 4. And honestly, we use 4 in all the other classes, so that's perfect. 5. How many times will 4 go into 20? 5 times. That gives us 20, and we have 0 remainder. When we have a 0 remainder, that means it goes evenly. That also means that this number has divisibility. That means something can go into it.
Doesn't 5 go into it even more?
Right, 5 goes into it evenly too. So 5, 4, and either one of those, okay? What we're focusing on here is just saying if there's a number that can go into 20 evenly, that makes 20 have divisibility. That means it can be broken down, divided up evenly. Okay? Our next key term is prime number. Prime number has only 2 factors, 1 and itself. Okay? We went through and we found all the prime numbers between 1 and 100. You guys remember that? So you have a chart. You have a chart for that. But there's still another way that we can check. Okay? When we're talking about numbers, we're talking about whether it's divisible, whether it can be broken down. We're also talking about if it can be grouped evenly. Because to divide something is to break it into equal groups. Okay? We can actually check for prime and composite the same way. And here's one way we can do it. Let's take the number 7. And it's going to be our example for a prime number. Okay? So, but we're going to use 7. The way we can check that 7 is prime is we can draw 7 squares connected together. Okay? Now, divisibility says that a number can be divided evenly or broken down evenly into groups. If we use squares, and you can actually take real squares. I have some if we ever need to test my theory or what I'm saying. Divisibility says we can take these 7 squares and we can rearrange them into groups. And what you should be able to make with them is another rectangle or even a square if you take those squares. Okay? Now, we have them all lined up in a row. So we have one row of 7. Do you think there's another way we can arrange those 7 squares so that it makes a rectangle? No. If we do 2 rows of 6, there's still one left over. So there's no way we can regroup them evenly to make another rectangle or square. That lets us know that this number is prime.
There is 2.5.
Well, we're just using the whole square, not like cutting it in half. That'll get us into something else. Okay, that's a good idea to think about. But just the squares themselves, we can't rearrange them to where it makes a rectangle. We can't regroup it evenly. Okay, so that means 7 is prime because we can't regroup it. Okay. Composite says it has 2 or more factors. That means that it can be rearranged a different way. So for composite number, we're going to use
4.
10. We're going to use 10. Okay? And we're going to draw 10 squares. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have one row of 10 squares. Is there another way that those can be rearranged, grouped evenly so that it makes a rectangle? Is there another way?
2 rows of 5.
We can do 2 rows of 5. And that's still going to give us even rows and it's going to give us a rectangle. 2 rows of 5. So that means that this is a composite number because we can rearrange those squares into different groups. Okay? So that's an easy way to check for to see if it's prime or composite. Think about, can we regroup if we had squares for that number? Can we rearrange that number into equal groups and make a rectangle or a square out of it? Okay? Now, for the number 9 and for the number 16, 9 we can do 3 groups of 3 and that'll make a perfect square. 16 will be 4 groups of 4 and that'll make a perfect square. So those numbers are actually called perfect squares. 9, 16, 25. We'll get into that a little more later, but just know they're actually using the whole square idea to come up with calling those numbers perfect squares. Okay? Any questions about those before I move the chem chart up? Okay. Make sure you have this drawn. Divisibility means that it goes into it evenly. Okay? That makes it divisible. Prime has only 2 factors. 1 in itself, and it cannot be arranged any other way. Composite means it has more than 2 factors. This one has 1, 2, 3, 4. Those numbers are the factors. The way that it can be grouped also give you your factors. Okay? So that's how we test for those. Any questions about that? Alright, I'm going to erase. Everybody have this drawn before I erase?
Yes.
Alright, now let's look at the others. Our next word, and this is what I like to call the $1 million word to make us sound smart. The fundamental theorem of arithmetic. Okay, you go and say that word around people, they're going to swear that you're the smartest person ever. But it's basically talking about prime factorization. Okay? So anytime you hear a fundamental theorem of arithmetic, they're also talking about prime factorization, which is why I underlined it. Okay? Another word you may hear, which I know it sounds like a science word, but for some reason we use it in math now too, is decomposed. That means to break your numbers down using factor trees. Okay? Now, I'm not sure if we remember what a factor tree is, but that's going to be our example. When we use the fundamental theorem of arithmetic, or we decompose, or we find the prime factorization, all means the same thing. Okay? That means we take a number and we're going to break it down into its prime factors. Okay? The way you start is, this is the top. You break it down into 2 factors. What are factors of 16? What numbers do we multiply?
4 and 8. No. 2 and 8. 2 and 8.
Okay, 2 and 8. 2 and 8. This is, remember, it's the factors are the numbers that we multiply together to get that. So 2 times 8. Okay? Once we see a prime number, I like to circle it, meaning that there's nothing else that I can do to it. So I'm going to circle the 2. 8 is not prime, so I need to break that down more. Okay? Factors of 8 are 2 and 4. Do you see anything prime?
Yeah.
The 2, so I like to circle it and break down the 4.
2 and 2.
Okay? Now, once we've broken everything down, that is our factor tree. Okay, actually it kind of looks like an upside down tree because, you know, trees branch out that way. They branch out the opposite direction. Now, we're not done because when they ask us to write the prime factorization of a number, it tells us to write all the prime numbers that we multiply together to get 16. So if we multiply 2 times 2 times 2 times 2, we should get 16. Okay? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that is the prime factorization of 16. That's the fundamental theorem of arithmetic using 16. That is decomposing 16 into its prime numbers. All this word, and that word means you're doing this. Okay? I just like to use fundamental theorem of arithmetic to make myself sound super smart. We'll get to that later. Yes. All right. Now, the next word is factor. And the memory device I'm going to use for factor is actually something that I borrowed from one of your classmates. It's just a simple thing, but I thought that's a good way to remember. A factor, factors are the numbers that are multiplied together to get a product. So you multiply factor times factor equal product. Okay? Factor times factor equals product. Now, a way that you check to make sure you're writing the right answer. A factor cannot be higher than the number itself. Okay? Let's fill this in with some numbers. 4 times 5 equals 20. What are the factors of 20 that we used here?
4 and 5.
4 and 5. Those are factors. A factor cannot be higher than 20. We can't say 40 is a factor of 20 because 40 is too big. Okay? We multiply factor times factor to get a product. Okay? So, and the product is 20. Because what's going to happen, we're going to start mixing factors and multiples together, and we don't want to get those confused. Okay? So remember, factor is the numbers that we multiply together to get the product. Right. Okay? So factor times factor equals product. And it's so simple, but I didn't even think of it that way until somebody in second period reminded me of that. So guys, sometimes you guys can be a big help to each other as well. So remember that. All right? And exponents. Exponents are something that can make our life really easy if we know how to work those correctly. Okay? And exponents tells how many times to multiply the base to itself, not the type of base that you associate with shapes. Okay? You have, for instance, we have 3 to the second power. 3 is our base, the big number. 2 is our exponent. And it's the little number. I just threw that in there so that you know it's the little number. That's the exponent. Okay? The way it works, it tells how many times to multiply this number by itself. Okay? Since there's a 2 here, that means we take this 3, the base, We write it down twice, and we multiply it together. Okay? So, 3 to the second power, which we can also say 3 squared. We'll talk about that. But 3 to the second power is 3 times 3, which is 9. Okay? So the exponent, the little number, tells us how many times to write out that big number and then multiply them all together.
I know what square is.
Okay? Well, squared is just another way to call that second power. Okay? Now, the last thing, it says you can also use exponents to group factors when we're doing prime factorization. Okay? You see up here when we did prime factorization, if we have a number that shows up more than once, we can actually make that number the base. We can make that number the base and use an exponent to show us how many times that number showed up. How many times did we write that 2?
4 times.
4 times. So we make the 4 our exponent. Because it tells us we multiplied that 2 together 4 times. Okay? So, if they give us an exponent, we can use that to write it out and find the value of it. Or, when we're doing prime factorization, if we write a number out more than once, we can use exponents to kind of bring it together, to put it together so we won't have to write so much.
On prime numbers, between prime and composite, if you divide a number by 2 and it's less than a whole, it's prime. That was on 2. Like on prime, instead of 1 in the number, if you divide it, it's less than 2. I mean a whole, then it's prime.
Right. If you have remainders, even though we don't use them, or decimals or anything, if it does not come out evenly, if you cannot divide it by a number of, if you cannot divide it by 2 or more, then it's prime. And the only factors it has would be 1 in itself. Okay? Are there any questions about your chem chart? Any questions about your chem chart? What you're doing, first of all, these dots here represents multiplying. We are going to use those dots for multiplying instead of the little X looking symbol, because we're going to talk about algebra this year. And the X is going to become a variable or a letter, which is going to mean something totally different. So we use this for multiplication. This is saying, remember, your exponent tells you how many times you multiplied a number to itself. So we multiplied 2 together 4 times. So instead of writing 2 times 2 times 2 times 2, we can just write 2 as our base and a 4 as the exponent. Okay? But what it says, 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So 2 to the 4th is this, which is also 16. Okay? So it's not decimals. This is a symbol for multiplying. Okay?
Algebra is like J times 2 equals 4.
Yes, but we'll get in that. We have plenty of time. Plenty of time to get into that, okay? But that's one of the reasons we're going to start using symbols like this to represent multiplication, because the X symbol, we're going to use X to mean other things, okay? Any other questions about the chem chart? Okay, the chem chart is hole punch, meaning it goes in your binder. You need to go ahead and take this home and start getting familiar with it, because if we have a quiz coming up soon, some of those things will come directly from this chem chart. Okay?